In this problem, we are given a graph of a function, and we're asked to find specific indicated values. Now, what you'll learn later on, this is a cyclical function. That means it repeats in a pattern infinitely. It doesn't necessarily always have to be infinitely, but in this case, it is. And in this case, we're looking at that it follows this pattern here. I'll start at negative 3 pi over 2. X equals negative 3 pi over 2. And if you'll notice, I go down, and then I come up, and I'm at the same point that I started at as far as the y values are concerned. It's going to repeat that pattern infinitely in both directions. That's what the arrows at the ends of the curve indicate. There are multiple trigonometric functions, especially sine and cosine, that are used extensively throughout the rest of your math courses, including this one. And it's important to be able to know how to interpret certain parts of those cyclical graphs, including trigonometric functions. So with part A, we're asked to find f of 0, and to do that, we simply go to x equals 0. What's the value of f of x at x equals 0? Well, it's just 0. What about when x equals pi over 2, or 1/2 pi? We go to x equals 1/2 pi, and then we go up and see that the value of the function at x equals pi over 2 is 2. Same thing with negative 3 pi over 2. If we go over here to x equals negative 3 pi over 2, go up to the curve, it's at, again, 2. Now, what are the values of x so that the function equals 0? Well, f of x equals 0 is the same thing as y equals 0. So where does this function equal 0 on our graph? It's at negative 2 pi, negative pi, 0, pi, and 2 pi. So the values of x where f of x equals 0, in this case, at least as far as on our graph, are negative 2 pi. So x equals negative 2 pi, negative pi, 0, pi, and 2 pi. But it goes on infinitely in both directions, so technically we should say that the values of x when f of x equals 0 are x equals pi times n, where n is any integer. If we plug in any integer, we're going to end up at for x. If we plug in any integer for n, we're going to end up with an x value where f of x equals 0. If we put in n equals negative 2, we're at negative 2 pi. N equals 1, we're at pi. N equals 0, we're at 0, so on and so forth. No matter what we put in for n, as long as it's an integer, we're going to be at f of x equals 0. Now we're asked for the x-intercepts. Well, that's, again, when y equals 0, or when f of x equals 0. So the intercepts we'll just list as points, but we have the x values already, and we know that the y value is simply going to be 0. So the x-intercepts, at least on our graph, are negative 2 pi, 0, negative pi, 0, 0, 0, pi, 0, and 2 pi, 0. And again, technically, we're not asking for this right now, but technically, the x-intercepts would be at pi n, or n pi 0, where n is any integer. But as far as our graph is concerned, these are the only ones that we can see on our graph. Now the y-intercepts, there's only one. It's right here at 0, 0. So our y-intercept is 0, 0. The domain, remember these numbers, or these arrows at the end of our curve indicate that it goes on infinitely in both directions, but that it repeats in the cyclical pattern. So the x values, there is no limitation. X can be anything. So in interval notation, this is going to be negative infinity, infinity. That's what the arrows represent. Now the range, even though it goes on infinitely in both directions, as far as x is concerned, it's going to repeat the same cycle, where the maximum we have is y equals 2, and the minimum we have is y equals negative 2. And it does include those So our range is going to be -2, 2. Now going back to the domain, we could say, if we're just using the graph, because we're not given a definition for f of x, we don't know what this function is, someone could make the argument, well, we don't know what it does after we get off of this graph. Technically, there should be little points at the end, closed circles, not arrows. But if we're going based on just the graph, one could make the argument that the domain is -2 pi, 2 pi. But that's just the domain that's shown. If we follow the same pattern, or if we're given that it's a cyclical function, then the domain would be -∞, infinity. And as always, if you have any questions about any of this, please contact your instructor. You can go to the help menu, and there's an option to ask your instructor a question, and it will send your instructor whatever message it is, whatever questions you have when you do that option. Or you could go to your inbox and message your instructor directly.